Alright, this one's going to be a bit off the cuff, so I'm definitely going to need to have some clarification on what to do and various other ideas as they come to be. I think one of the main understandings that I probably would have come to this conclusion regardless if I didn't make it with the evolved star conclusion where I have the iron in the center of a planet. Okay, that's how I made the conclusion in the beginning, and back in September of 2011. This definitely would have been the other way I would have made the conclusion that stars simply have to be young, hot planets. It's because of meteorites. Here we have the Hoba meteorite in Namibia is the largest known intact meteorite, 2.7 meters long and 60 tons. This thing is solid iron and nickel, okay? Iron nickel alloy to be exact, with trace amounts of gallium, iridium, things like that. But the way I would have made a discovery is the fact that you can't have things this big forming in vacuum in outer space from rocks and metal just clumping together. I'll go over a list for you of things you need to have this massive amount of iron and nickel clumping together in outer space. I made a little list here. Now I was looking at refractory material. I was looking at smelting processes. Now, this is going to be off the cuff, so I'll just try to do my best to explain it to you guys. The vacuum of outer space is very different than stars, and I'll go ahead and show you why stars just simply have to be the place for this iron nickel to collect in the center, forming the planet, and why the vacuum of outer space, as per establishment dogma, is highly out of date and misdirected, just completely misdirected. They don't know what they're doing at all, but I'll try to be nice to them. The vacuum of space, does it have refractory material? Now, refractory material is things that block heat, like heat bricks or steel containers. I'll go over that in another talk. I just want to go over the overview right here, make it nice and short. Does it have refractory material? No, the vacuum is vacuum. There's no material at all. With stars, is a refractory material? Yes, it has a very thick atmosphere and it can hold in a whole shitload of heat for many, many billions of years. So, check. The vacuum of outer space. Does it reduce material to remove impurities to make the iron and nickel pure, as in the meteorite? No, it doesn't have any material in outer space. It's vacuum. Okay. Sure, you have charged particles, but that doesn't remove impurities. It would just be a big clump of matter. With stars, you have reducing material to remove impurities. The plasma itself can reduce the material. It can take all the oxygen and all the nitrogen and all the hydrogen out of that material and reduce the hell out of it to make it pure. So check. Does the vacuum of outer space have strong gravitation to bring all the material together? No, the vacuum doesn't have any gravitating body. So how do you make a big iron chunk like this when there's no gravity present? Okay, that's weird. Does a star have strong gravitation? Hell yeah. Combustion material for heat, such as the fuel, which is coke, and the oxidizing material, the coke and then the oxidizing material, the oxygen. So you have your fuel and your oxidizer. That's with rocket fuel, okay? With rocket fuel, it's liquid oxygen, liquid O2, and then sometimes it's refined kerosene, or I think it's liquid hydrogen. I think that's how you put it. But anyways, you have two materials there that combust together and make a whole shitload of heat, okay? Does the vacuum of outer space have that? No, it does not. Stars. Do they have combustion material for heat? Are they comprised of coke and oxidizing material? Not exactly, but the star is actually very, very hot, okay? Stars are so hot that we can actually measure how hot they are. They're around 5,000 degrees on their surface. I guarantee you that thing can melt down anything, vaporize anything, and even ionize anything that comes in the vicinity. So the combustion material isn't exactly required because the star is already really hot. it makes all that material hot. So yes, it's not combusting. It's not like a fire. The star isn't like a fire, but it is really hot. So yeah, outer space versus a star and melting and making things hot. There's hands down the star wins. Process for removing slag. Okay, for instance, I'll go over this in another talk, but slag is essentially the impurities or heavy impurities that are on top of the iron and nickel when it falls to the bottom, and you just scrape it off the top. So say you have a big container and you have, the slag on the top, and the iron and nickel sink to the bottom. So you can scoop all that off, or maybe you can have like a little well where it just can siphon off, and then you have a tap on the bottom where the iron and nickel pour out, and it's called pig iron, and you can remove it that way. So does the outer space have does the vacuum of outer space have a process for removing slag, and can that also it's the same argument as the reducing material, but basically you have that. Now, do stars have processes for removing slag? Sure they do. Markland convection, the critical ionization velocity of the material. You have a whole bunch of things that can remove the impurities and or the slag. Okay? Now you have outer space, vacuum of outer space. Or actually, I forgot to do this check mark. Yes. You have outer space. Is there pressurized air to sustain combustion, to keep it hot? Outer space doesn't even have any air at all. Okay? There's no way to keep it hot. Now, does a star have pressurized air to sustain combustion? Now, I'm not saying it's combustion happening in a star, but I'm saying, is there pressurized air? Hell yes, there is. The whole thing is a giant gas ball when it evolves from its plasmatic state. So it shrinks, cools, and dies, and becomes a giant compressed gas ball as it forms the iron and nickel core in the center. There's a whole shitload of pressurized air, to many gigapascals. I'll talk about that later. So basically you have, at the very end of this, a meteorite, such as the Hoba meteorite, cannot form or even be smelt in the vacuum of outer space, as per the nebular hypothesis, outside of a body, outside of a star. Probably not. Probably not. What they do is they ignore basic smelting processes, basic understanding of what it takes to melt down material, to purify material, and to keep material hot. Can a star make something really big like the Hoba meteorite? Sure it can. It falls all toward the central regions of the star, and as the atmosphere dissipates, it leaves the little hard, rocky, differentiated ball in the center. That's what a planet is. Of course it can. And then you have these objects slamming into each other, making huge fields of shrapnel, and that's what the Hoba meteorite was. It's just a big chunk that came off of one of those impact events. And I did some math calculating the radius of the sphere of the inner core, or the volume of the sphere of the inner core of the Earth. And it's sitting at 1,220 kilometers is the radius. This is the inner core. This is a giant iron nickel ball. EL. Okay? That's in the center of the Earth. And I calculated this, and it turns out it's 7.6 billion cubic kilometers. Okay? That is a vast sphere of iron nickel alloy. That's what something a star makes. But people, they just ignore this. Why do they ignore it? Because they don't have any explanation for how it forms. Obviously, the smelting process of a star is what forms that iron nickel core in its purified form. Now, for a later talk, I have more notes on the side. Hang on one second. I want to go over the fact that if you have outer space, okay, say there's iron in outer space. Say this little area out here is outer space. If you have iron, and you get it real hot with like a blowtorch. Imagine something like this happens. Okay, you have matches, and then you have aerogel on the bottom, which is extremely efficient synthetic insulator and has a very high R value. R value means resistance, basically resistance to thermal decomposition. I think that's what it means. But basically, you have an insulator, and here's a blowtorch underneath it, and that blowtorch is right underneath that insulator, preventing the matches from getting hot. Now, that insulator prevents those matchsticks from getting hot. With the nebula hypothesis, they say, well, somehow this star is supposed to get material hot from many billions of miles away. Many, many millions of miles. How is that possible? Especially when you have a vacuum in between it. And now it says vacuum insulated. That's not only the only thing. If you add billions of miles in between something like the Hobo meteorite and the sun, guess what? You're not going to be able to get it hot, because look how high that R value is. It's one of the most thermally resistive material you have out there. So basically, they're ludicrous to believe that the sun melts down things from outside of the bodies. And well, that's about it. I mean, I'll go over this other stuff to clarify in the future. I printed out this nickel, I have its melting temperatures. I printed out iron, and I printed out refractory metals. Now these are refractory metals. These are metals you can hold other metals inside of to get hot. I don't know why they didn't put carbon on there. Where's carbon at? Carbon. AB. Carbon should be like up here somewhere. That's weird. I don't know why carbon isn't even on here. Okay, that's weird, because there's a lot of carbon crucibles made that can melt down all these other metals on this area right here. But these metals, such as tungsten, which is I think that W, are made of light bulb filaments. So it's really, really hard to get them hot to melt down. And they have the melting point. It's really, really hot. Go ahead and put this up for you guys to look at that. Very interesting stuff here. I'll go over this later. But basically, you have astronomers. They don't understand what it means. They don't understand what it means to make metal pure and in large amounts in outer space. They think it just clumps together because of gravity. I challenge them to find a iron worker that can melt iron with gravity alone, just by taking iron and setting it on top of other iron, and just to see if it melts down and purifies itself. I think they're crazy to believe that. All right, later, y'all. Oh yeah, Baz, if you have any more suggestions or questions, just don't hesitate to ask.